Imagine a substance so powerful that the moment it meets its twin, both vanish in a flash of pure energy. A rarity so extreme that a single milligram would cost more than the entire global economy combined. Now, what if I told you this isn't the stuff of distant science fiction, but a real player in the universe, right at the frontier of modern physics? Welcome to the mysterious, mind-bending world of antimatter. To understand antimatter, picture the universe in a mirror. Every particle that makes up your body, your atoms, your cells, the very essence of who you are, has a counterpart. But in this mirrored realm, every property is reversed. Take the humble electron. It carries a negative electric charge and orbits the nucleus of every atom. Its mirror sibling, the positron, is identical in every way except one. It carries a positive charge. Likewise, the proton, that hefty building block of the atomic nucleus, has its opposite, the antiproton with a negative charge. For every piece of matter, there's an antimatter twin. Now, when these opposites meet, the universe doesn't allow for small talk or compromise. Instead, it orchestrates one of the most dramatic dances in all of physics: mutual annihilation. In a heartbeat, matter and antimatter erase each other from existence, and all that remains is a burst of raw energy. It's as if the universe is saying, "Here, have pure energy," in a blinding flash. This isn't just a poetic metaphor. This is energy at its most potent, the ultimate transformation. This dramatic event is described by perhaps the most famous equation in science: E equals mc squared. A little bit of mass, multiplied by the speed of light squared, yields a staggering amount of energy. It's this very principle that powers the sun, and in theory could propel spacecraft to distant stars. Indeed, some of the world's most imaginative scientists have seriously considered using antimatter as the ultimate rocket fuel, a propulsion system that could one day carry humanity across the cosmos. But there's a cosmic puzzle at the heart of this story. If antimatter and matter are such perfect twins, born in equal measure from the Big Bang, why does the universe look the way it does? Why is almost everything we see made of matter, with so little antimatter around? If the laws of physics treat both with perfect symmetry, shouldn't they have annihilated each other completely, leaving behind a universe awash only in energy? The fact that we exist at all is a clue, an open question that drives physicists to search for answers. Somewhere hidden in the laws of nature is an explanation for this cosmic imbalance. Now, making antimatter isn't as easy as flipping a switch. It's perhaps the most expensive manufacturing process ever devised. To create even a few particles of antimatter, scientists use massive machines called particle accelerators. The Large Hadron Collider, buried beneath the border of Switzerland and France, is one such behemoth. These accelerators consume staggering amounts of energy, hurling protons at nearly the speed of light, smashing them together, and very occasionally producing a fleeting antiparticle. For all that effort, the yield is vanishingly small, measured in billionths or trillionths of a gram. And the challenge doesn't end there. Antimatter's most inconvenient property is that it can't touch ordinary matter at all. Otherwise, both are instantly destroyed in a blaze of gamma rays. Imagine trying to store a snowflake in a furnace. To keep antimatter safe, scientists have to suspend it in a vacuum, held in place by intricate webs of magnetic fields. These containment devices, called penning traps, are marvels of engineering, using powerful magnets and the emptiest spaces we can create to keep antiparticles from touching anything, literally anything else. These traps are delicate, expensive, and among the most sophisticated instruments ever built. The cost of producing and storing even a milligram of antimatter? Around $25 quintillion. Yes, you heard that right. A number with 18 zeros. It makes gold, diamonds, and even the most valuable artifacts on Earth look like pocket change by comparison. It's no wonder that, for now, antimatter is the world's most expensive substance. But why pour so much effort and ingenuity into something so ephemeral and costly? The answer lies in the transformative potential of antimatter. Studying it could unlock the secrets of the universe's birth, help us understand the deep laws that govern matter and energy, and maybe, just maybe, point the way to new forms of technology and propulsion, from medical imaging to interstellar travel. It's a scientific moonshot, difficult, uncertain, but with the possibility of revolutionizing our understanding of reality. You might wonder, if antimatter is so distant from everyday life, what's the point? Why not leave it to the world's largest labs and most ambitious governments? The real answer is that science thrives on curiosity. It's not just about what we know, but about exploring the unknown, asking the questions that seem impossible, and daring to imagine what might be. Antimatter challenges us to think differently, to push the boundaries of what's possible. And here's the exciting part. You don't need billions of dollars or a particle accelerator to start your own journey into the world of antimatter. There are interactive tools and simulators online that let you step into the shoes of a particle physicist. The CERN Hypatia project and the Atlas data portal offer free access to real collision data from the world's most advanced experiments. You can see for yourself how particles are created, how they interact, and even try to spot the telltale signatures of antimatter. For a more playful introduction, there are games like Particle Clicker, which lets you run a virtual particle accelerator, or the PhET simulations from the University of Colorado, where you can play with magnetic fields and see how they steer charged particles. These platforms make physics not just accessible, but fun, inviting you to experiment, explore, and discover. Even if you can't make antimatter at home, you can still get a feel for the principles behind its storage and manipulation. Simple experiments with iron filings and magnets show how magnetic fields work, an essential concept for trapping and controlling antiparticles. Building your own basic circuits with coils and sensors can give you a hands-on sense of how accelerators guide particles on their high-speed journeys. But science isn't just about experiments and equations. It's also about imagination. Draw, write, invent stories set in worlds where antimatter is abundant, where its properties are woven into the fabric of civilization. The greatest scientific revolutions often begin with a simple question: what if? By daring to imagine, you become part of the same tradition that led to the discovery of antimatter in the first place. At the end of the day, antimatter may be invisible, fleeting, and outrageously expensive, but its real value isn't just in the particles themselves. It's in what they represent: the human drive to dream big, to ask hard questions, and to turn the impossible into reality. Our curiosity is the true treasure, the force that propels us forward, from the tiniest particles to the furthest galaxies. If you're captivated by the mysteries of the universe, if you find yourself looking up at the night sky and wondering, what if? Then you're already a part of this adventure. The journey of discovery belongs to all of us, not just the scientists in their labs, but everyone willing to ask and imagine. So, if you're ready to help crack the greatest mysteries of existence, to push the frontiers of what's possible, stay curious, stay engaged, and keep asking questions. Join us in exploring the wonders of the universe and be part of the next revolution in human knowledge. If you want to help unravel the secrets of the cosmos, keep following the curious order. Like this story, share your questions and wildest theories in the comments, and spread the wonder to anyone who loves science, fiction, or simply gazing at the stars and dreaming of what might be. Subscribe to stay on the front lines of discovery, and together, let's shape the future of knowledge.